All right, here we're looking at section 7.4, and our essential question is how can you determine the domain of the sum or difference of two rational expressions? Now when we're dealing about sum or difference, right, we're adding and subtracting, and the domain is all my possible x values. So I just want to keep in mind any x values that would make my denominator 0. Those are not possibilities, so we want to just think about that as we're going through. So our learning targets for this section are to add or subtract rational expressions, and then we're going to be rewriting rational expressions and graphing the related function, and then we're going to be simplifying some complex fractions. So here's our first core concept. We're adding or subtracting with like denominators. And just like we did with numbers, right, as if my denominator is the same, I just add or subtract the numerators and keep my denominator the same. So let's look at example number 1. So I see that if I have 7 over 4x plus 3 over 4x, my denominators are the same. So I go ahead and I add my numerators, and I leave the denominator alone. So we can simplify from there, so I end up with 10 over 4x. But before I'm completely done, I have to make sure that it's as simple as it can be, and I notice that both the numerator and the denominator are divisible by 2. So I go ahead and do that, and so my final answer would be 5 over 2x. So let's look at part B. First thing I see is that my denominators are the same again, so I can go ahead and I subtract the numerators, and I leave my denominator alone. So now I want to look and I see, can this be simplified? Which it can't, so I can leave that as my final answer. Okay. So here are your first monitoring progress. Try them and see what you come up with. So here's our second core concept. This is when we're dealing with unlike denominators, right, where they're different. So the first thing I have to do is find my common denominator, and then I can either add or subtract my numerators. So let's look at if this was numbers. So if I have 1/2 plus 3/5, well, I can't add those because the denominators are different, so I have to find that common denominator, and I go ahead and I multiply those two together. So then to find my new numerators, I multiply the original numerator times the opposite denominator, and then I can simplify from there. So I end up with 5/10 plus 6/10. So now that my denominators are the same, now I can add my numerators. So this is something similar to what we're going to be doing with our rational expressions. So the first thing we want to do is find our common multiples, and our least common multiple will help us to find the most common denominator, the easiest denominator. So the first thing I want to do is I want to factor out everything that I can. So I see I have 4x squared minus 16. So the first thing I notice is I can factor out a 4 from both terms. So I end up with x squared minus 4. Well, now that I see my 4 can be factored just a little bit, 4 can also be written as 2 squared. I also notice that this is a difference of 2 squares because I know the square root of the first term and I know the square root of the second term, and I'm subtracting. So I end up with x plus 2 and I end up with x minus 2. So now this first polynomial is completely factored. So now let's look at the second one, 6x squared minus 24x plus 24. So I notice that I can factor out a 6 from all of the terms, so I end up with x squared minus 4x plus 24. Oh, I'm sorry, plus 4. So now I want to factor this trinomial. My 6 doesn't go anywhere. And in reality, let's factor out that 6, right? Because I want to go as small as I can. So I know that 6 can also be written as 2 times 3. And I know that this polynomial is going to be factored into something else. So to do that, again, I look at my constant term, and I know that it can be 2 times 2 or 4 times 1. And they are either both going to be positive or both be negative in order to get this middle term. So I know that I can add a negative 2 and a negative 2 to get my negative 4x. So now that both have been simplified, I want to simplify this just a little bit more. So my 2 stays there and my 3 stays there, but this can also be written as x minus 2 squared. So here are the things that I'm really going to be looking at here now to find my least common multiple. Oops. So on page 385, it explains what our least common multiple is. So our least common multiple is the product, so I'm multiplying, of the highest power of each factor that appears in either polynomial. So I want to find factors that are the same in both polynomials and take the one that's the highest, that has the highest power. So I see that I have a 2 as a factor in both polynomials. And here in this first one, the factor exponent is higher, so I'm going to take that one. Okay, so I've dealt with those 2's now. I see that I have a 3 here. I don't have a 3 over here, so I know that that's going to just be the highest power there. Here I see I've got an x minus 2 and an x minus 2, and my power in the second one is highest, so I'll take that. So x minus 2 squared. So my x minus 2's have been taken care of, and what's left is this x plus 2 here. So I'll include that as well. So now I can just simplify a little bit. So 2 squared is 4 times 3 is 12. My x minus 2 squared stays, and my x plus 2 stays. So this right here is going to be my lowest common multiple of the 2 polynomials that are given above. So now I'm looking at example number 3. We're going to find the sum of these 2 polynomials. So the first thing I want to do is I want to look at this first method, right? And we have multiple methods and we can do things multiple ways. So let's look at both methods. So this goes along with that core concept, right? Where I multiply my denominators together to get my common denominator. I multiply the numerator of the first one by the denominator of the second one, and the numerator of the second one by the denominator of the first one. And I write those out to get my new common denominator. So then I use the distributive property, and I simplify what I have. So then I notice from the numerator I can factor some things, and I also see that I can factor out something from this polynomial in the denominator. So since I have a 3x in the numerator and a 3x in the denominator, I can factor that and divide that out, and then just finally simplify that one. Okay, so now let's look at method 2. So method 2 is where I'm going to be finding my least common denominator by my least common multiple. Okay, so the first thing that I do is I factor both of the denominators. So my 9x squared becomes 3 squared times x squared, and my 3x squared plus 3x becomes 3x times x plus 1. So the things, right, I see I have 3, but this one's bigger, so I've used my squared. I have an x, but this one's bigger, so I use my x squared, and I have this x plus 1. So my least common denominator is 9x squared plus x times x plus 1. So now that I have that, I factored out, and I can continue on. Okay, so I've written it in factored form. So now I have to figure out what I'm multiplying by. So this first fraction already has the 9x squared part of my denominator. So the only thing that's missing is this x plus 1. So that's what I multiply both the numerator and the denominator by. So for the second fraction, I see that the only thing missing is this 3x, so I multiply by 3x over 3x. Then I just multiply through and I simplify. So now I'm going to add my numerators, and I don't have anything I have to factor out or simplify from there. So now let's find the difference here. This is example number 4. So the first thing I want to do is I want to factor each denominator. So I notice I can get a 2 out of both of those terms, so it becomes 2 times the quantity x minus 1. This denominator can factor to x minus 1 times x minus 3. My numerators haven't changed at all, so first I factor. Then I'm going to find my least common denominator, which I see a 2. I have this x minus 1, which is common, and then an x minus 3, so that's my least common denominator. Now I have to figure out what each term is missing, each fraction is missing, and multiply by that. So my first fraction I multiply by x minus 3 over x minus 3. And then my second fraction I multiply by 2 over 2. So then I multiply and use the distributive property and simplify. So now here's the big part. I have to take this subtraction and I have to distribute that subtraction sign to everything that's behind it, okay? So here's the big thing. You want to always use your parentheses here. So you see I have my entire numerator in parentheses so I can have this subtraction. So then I'm going to end up simplifying, because it does end up becoming, if I distribute this here, x squared minus x minus 6 plus 4x plus 2, it ends up simplifying to my x squared plus 3x minus 4, and my denominator stays the same. So now I can go ahead and I can factor out my numerator, right, which becomes x minus 1 times x plus 4, and I divide out any common factors. So here's where I wanted to talk a little bit. So you'll see here that the thing that's the same is this x minus 1 in both the numerator and the denominator, so I can get rid of that. And now that I've gotten rid of those, I can go ahead and I simplify. So I end up with x plus 4 in my numerator, and my denominator has 2 times x minus 3. So I am thinking about values that I need to exclude, right? Remember, we're talking about the domain. So I want to look at what would make this 0. And so just think about those as we go. So here is going to be our final answer for that one, for when I'm subtracting. The biggest thing to keep in mind when you're subtracting is when I have that subtraction sign, I have to use these parentheses so that I can distribute the subtraction to everything that follows. If not, it's very easy to lose that subtraction sign, and then you will end up with very different results. So here are some more monitoring progress. Try them and see how you do. Especially like this number 8, try the big ones, because if you can do those, then you know for sure you'll be able to do the easier ones. So here we're going to start looking at our second learning target, which was rewriting rational functions. So now I have to rewrite the function 3x plus 5 over x plus 1 in my standard form, right? A over x minus h plus k, and then graph it. So we've done that before. You used division of polynomials. So here we're going to do it by what's called inspection. Okay? So what I can do is I can break this 5 into 2 pieces, because 3 plus 2 is the same thing as 5. This is very similar to factoring by grouping, which is actually what we're doing here. So I broke this down because I know I have a 3 here now and a 3 here. So I can factor that 3 out. And then I see I have something common in my numerator and my denominator, which ends up being my x plus 1. So the one step here that they don't explain very well is how I get from this part to over here. So I know that I have, when I'm adding fractions, my denominator has to be the same, but I can also take fractions apart. So I can look and I see that this part would be one numerator, and this part would be a second numerator. My denominator stays the same for both of them. So I've just, I've decomposed my fractions. I've broken them into pieces. Rather than adding them together, I've broken them apart. So now I can get rid of this x plus 1. So now I have 3 plus 2 over x, the quantity x plus 1. So now it's rewritten, right? I can just change the order. So I also know that it's a translation 1 unit left and 3 units up of my parent function, which would be 2 over x. And this is approximately what it looks like, right? The biggest thing here when we're graphing these rational functions is to know where my asymptotes go, and then I can draw a rough estimation of the graph from there. Okay, so here is a practice one. So go ahead and try doing this the same way we did here, using our inspection instead of actually doing the division, because we need to be able to do things several different ways. So now we're going to be looking at complex fractions. Okay, this is our third learning target. So there's a couple of methods that we can do to simplify these complex fractions. One of them is simplifying the numerator and the denominator by writing them as each one is a single fraction. And then you divide, and when we divide fractions, we multiply by the reciprocal. Or the second method is I can multiply the numerator and the denominator by the lowest common denominator of every fraction in the numerator and denominator, then simplify. So I'm going to show you a couple of examples of these. Okay, so here is what a complex fraction looks like. It's a fraction that includes many other fractions. So the first thing I want to do is I want to go ahead and deal with my multiple fractions in the denominator. I'm going to go ahead and add them together. And since I see that they have unlike denominators, I have to find my common denominator where I just multiply the two together. Let's see how we do that up here. So I'm going to end up with my denominator of x times x plus 4 and a new denominator of x times x plus 4. So to get my first numerator, I start with what I had times the denominator of the second one. And over here I have start what I had and use the denominator of the first one. So now I end up with x plus, and I distribute here, 2x plus 8, which ends up being 3x plus 8, which is what we ended up with right here. So all I've done is I've added the things that I could, right, to kind of start by simplifying my denominator. So now I'm going to multiply by the reciprocal, right? And I'm using the reciprocal of the denominator. And I do that because if I multiply the denominator by the reciprocal, it becomes 1. So that means it really kind of goes away. So now I'm going to just multiply the entire thing by the reciprocal. So when I'm multiplying, I multiply straight across, right? And I see that I have some common factors that I can get rid of. This x plus 4 is common in both the numerator and the denominator, so I go ahead and get rid of those. And then I just simplify what I have. So I know, too, that x cannot equal a negative 4, because if x right here was a negative 4, I can't have that because it would end up being 0, and I can't have 0 in my denominator. And same thing here. I would see in my original equation right here, if x was negative 4, I would have 0. And if x was 0, I would have 0. So we go back to our original equation to see where any excluded values would be. So that's where these come from. Not so much here once we figured out, but back at our original equation, that's where our changes come into play. Okay, so that was our first method, right? I literally just kind of simplify what I can and then I multiply by the reciprocal. So let's look at the second method. So the lowest common denominator of all the fractions put together is going to be that x times x plus 4. And I'm just going back so we can see everything together. Because I see I have an x plus 4 in this fraction, I have an x in this fraction, and an x plus 4 in this fraction. So I want to look at all three pieces. And the lowest common denominator is going to be that x times x plus 4. So now I multiply the numerator and the denominator by that lowest common denominator, and I divide out any common factors that I see. So this x plus 4 cancels out here, this x plus 4 cancels out here, and my x cancels out. And then I can go ahead and simplify what I have. And you'll see here, right, I can just go ahead and do my distribution here. And again, I'm just stating the restrictions on my domain, that these values I cannot actually have. So either method will get us the same thing. So here is your monitoring progress. Try these and see how you do. So let's look back at our learning targets to see how we did. Okay. So the first one was to add or subtract rational expressions. And we looked at two different ways we could do that. We can literally just look at all the pieces and then go from there. Or we can find our lowest common denominator and then add or subtract them. The second learning target was rewriting rational expressions and graphing the related function. This is another way that we can rewrite the expressions. We've done this before by division, and now we're just using a different way. And then our final thing is simplifying complex fractions. This is something that will come into play a lot in the future, so we always want to look to simplify, and either method works. It doesn't matter to me which one you try, right? Because we showed both methods here. And pick the one that works the best for you. So now that we've met our learning targets for this section, I want you to go ahead and start working on the homework.